Okay, so today I'm going to teach you guys how to use the trig ratio to solve for the measure of an angle within a triangle. So first of all, let's just review our trig ratios. Again, the way we remember that is so, to. Okay, so to remind you, so the so, that stands for sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Okay. Alright, so just like when we had all those steps laid out for solving for sides, we're also going to write out the steps to solve for angles. So if you have your notes, these are going to be the same problems in the notes, but if you don't have them, you might want to pause it and go ahead and draw these triangles so you can follow along and be able to get the right answers with this. Okay. Alright, so let's go ahead and talk about the steps. So the first step, same as the first step as we've been doing with all these problems, is to just label your triangle. Okay. So for number one, we're solving for angle A, so let's go ahead and label angle A as theta. Alright, and then we can go ahead and label our sides. So the 14, if I look at that 14, well, that's the longest one, and it's the one across from the right angle, so I know 14 is the hypotenuse. Let's look at how we're going to label 10. Well, if I draw an arrow from theta to 10, I did not go across the whole triangle, so that's why that one is going to be adjacent, and then this one would be opposite. There's not a number over there, so we don't have to worry about that one. So again, go ahead and circle your label and your numbers. Alright, so that was step one. Just label your triangle. Step two, similar to the last class we talked about solving for your sides. Step 2 and 3 are also going to be the same. Step 2, we're going to figure out which trig ratio are we going to use to solve for this angle. Okay, so again, that's why we circle these. So find which ratio up here has adjacent and hypotenuse. Well, that's going to be cosine. So I know for number one, I'm going to be using cosine equals adjacent over hypotenuse. Alright, so if you remember from last class, our third step is going to be to plug in. Alright, so theta is what I'm solving for, which is A, so I'm going to plug that in for theta. For adjacent, I'm going to plug in 10. And then, of course, for hypotenuse, I'm going to plug in 14. Okay, so this is where it's going to be different from solving for sides. Solving for sides, our fourth step was to cross multiply. But when we're solving for angles, we don't need to cross multiply. Instead, we're going to do something called inverse trig functions. Okay. So we have 3 inverse trig functions, and of course they all correspond with one of their trig functions we already know. So for sine, we have inverse sine. For cosine, we have inverse cosine, and for tangent, we have inverse tangent. Alright, so what that means is in order to isolate this A, because remember that's what we're solving for, in order to isolate that, we have to do something called the inverse cosine of this side. Okay, that will cancel out the cosine function and leave us with A. But you learn from algebra that what you do to one side, you also have to do to the other side. So I also have to take the inverse cosine of this side. Okay, so again, on this side, I'm just left with A. This side, we can actually plug this into our calculator. Okay, so most of y'all probably don't have a graphing calculator at home. Luckily, there's one online that we can use. It's pretty easy to use. And this is the URL that you're going to type in to get to it. So it's just desmos.com/calculator. So I'm going to type that in here. Alright, I've typed mine in a lot so it shows up automatically. Alright, the very first thing we're going to do on our calculator is we're going to change it to degree mode. Don't really worry too much about the difference right now. If you go into pre-cal, you learn about that more, but just for our class, for our purposes, just remember always put it in degree mode before you start. Otherwise, it's going to mess up all of your answers. Okay, so to type stuff into your calculator, you're going to click down here where it says show keypad. Alright, so what we need to type in is inverse cosine of 10 over 14. Alright, so if you click the functions button here, the first screen that shows up is all the trig functions. So there's our sine, cosine, tangent, and then right next to it is our inverse sine, inverse cosine, inverse tangent. Okay, so again, for a problem, we're going to do inverse cosine, and then, and it's going to be 10 divided by 14. And then you go and hit enter, and then there's our answer right there, 44.42. So remember, we're always going to round to 2 decimals. Remember, we're solving for an angle here. Well, we measure angles in degrees, so your answer for all of the questions where you're solving for an angle should have degrees in it. 44.42 degrees. Alright, let's go on to number 2. Okay, so again, let's go through our steps. First step is to label our triangle. We don't need to label theta because in this problem it's already labeled as theta. Should be. Alright, so 20 is going to be my hypotenuse. So again, that's the one that's across from the right angle. 14, well, if I draw an arrow from theta across to 14, that's going to be opposite. Okay, so now let's pick the ratio that uses opposite and hypotenuse. Well, that's going to be sine. Alright, so far we've labeled, we picked the ratio, and now we're going to plug in. So again, in our problem, it's already labeled as theta, so we're just going to leave that as theta. For opposite, I'm going to plug in 14. For hypotenuse, I'm going to plug in 20. Okay, so I've done steps 1 through 3. Now the last step is do the inverse trig function of both sides. Okay, so to make sure you pick the right one, well, the inverse function goes with each one. So here we had cosine, so we did inverse cosine. So here, since we have sine, we're going to do the inverse sine of both sides. Okay, so this cancels out, so I'm left with theta. I'm going to go to my calculator to plug this in. So again, go to functions, inverse sine, 14 divided by 2, 0, hit enter, and I got 44.43 degrees for that one. Alright, one last example. So here, we're going to solve for angle B. Step 1 is we're going to label. I'm solving for B, so I'm going to label that as theta. This is the hypotenuse. There's not a number with it, so I'm not going to worry about labeling that one. Alright, so I had to go across the triangle to get to the 4 from theta, so that one's going to be my opposite, which leaves 7 to be my adjacent side. Alright, so the ratio that uses opposite and adjacent, that's going to be tangent. So tangent theta equals opposite over adjacent. Okay, so there's step 1, there's step 2. Now step 3, I'm going to plug everything in. So for theta, I'm going to plug in B. That's what I'm solving for. For opposite, I'm going to plug in 4. And for adjacent, I'm going to plug in 7. Alright, so if you're getting stuck here, remember, just go back to your steps. Okay, the 4th step is to do the inverse trig function. Okay, so here I have tangent, so to get B by itself, I'm going to do the inverse tangent of both sides. Alright, so that cancels out, and I'm left with B. And then again, I'm going to go back to my calculator. Go to functions, inverse tangent, 4 divided by 7. You can do the equal sign or the enter button. Oh, sorry. Just kidding. Don't do the equal button. Just hit enter. Alright, we got 29.74 degrees for that one. Okay, one big thing with these problems, one easy way to check is make sure your answer makes sense. Okay, first of all, a couple things that we know that the angles that we're solving for have to be acute, so they have to be less than 90. So if you get something bigger than 90, then you know you're doing something wrong. Or, our answers are never unusually small, so let's say you forget to put it in degree mode, you left it on radian mode. Okay, our answers would never be this small. We've never done a problem where we had that small of an angle. Okay, if it was that small of an angle, it'd look like probably smaller than that somehow. Okay, so make sure you're checking your answer to see if it makes sense. Okay, these are reasonable answers. If you get anything smaller than that, double check and make sure that your calculator is in degree mode. Alright, there you go.